solution time. Why am I down here? Go up there. Let's go over here. So what I'm going to do, actually, I need to be smaller. I believe the manual says to make a new page. Don't really need to. You can drag everything onto the same page, and then we'll be able to see it at the same time. So what I'm doing there is these are all the displays. Currently, a table is out there. That was what you were provided. I am going to drag a graph on there because from here, sure, I could copy and paste everything and put it in an Excel. But if you're just getting a slope relationship, Capstone's pretty easy to do that with. Once we start doing error analysis and finding averages and means and all that stuff, any kind of average of a data collection, we do that in Excel. Here, we can just do this. So we know that we would like the force to be the independent variable. Oh, I keep messing them up. Hide floating meaning controls. This is the dependent variable because it's the y in our, if this looked like y equals mx plus b, this would be y. So that's our oh my gosh, dependent variable. And so we're going to put it on the y-axis. Now I'm going to say select measurement because right now it's just a blank graph. There's nothing on either axis. But notice my data has some units. So I'm going to put all this data on the y-axis, force. And then down here, I'm going to put the distance because that is my x in the y equals mx plus b. And then m would be negative k. So in my case, how am I going to get this? What we can do is we can get rid of these lines. Somehow, I kind of forget how, to be honest with you. It's in the manual. No. Is this it? So what I'm doing here, this little I symbol, instead of holding your mouse, so what you can do is you can hold your mouse over any of these things and it will tell you what it does. This is the thing we're about to use. Actually, will it just go away? Will the line between it just go away if I do that? No, it'll add an extra one. So we'll get to this in a second. What I did was I just fit my data to this equation. What we can do, later on in lab when we actually have some good data and bad data, there's nothing telling you that this isn't good data. It all kind of fits along a line. What we can do is say, okay, maybe everything in this area, the carts hadn't smashed together yet or something like that. And this is the good data. So you see how my fit changes based on where I use this highlighter function. So it selects the range of points that I want to actually analyze. Right? So it gets more steep over here, less steep over here. If I want to do an average of my entire experiment, like as I said, there's nothing to tell us that this data is bad. Can't quite grab it. There we go. Is that big enough? One thing you'll notice here, I'll show you. I'm gonna zoom in and out. On the Mac, it's just pinching. Where is it? Zooming in and out on Capstone is a recipe for disaster. Well, it's already a recipe for disaster because I can't see all my stuff. So what I'm going to do is I'm going to go over to this button. This is your best friend. Click that button and it automatically includes all your data. So I know that my highlighter box is indeed getting everything. And it's back to the value that I started at. Let's try to figure out, I could just look at the little manual. Perfect. Smoothing. Nope, I forget. Let's consult. And the reason we're doing this is ultimately we don't want to, like, those connecting lines they don't tell us anything. It's quite literally just something that Capstone puts there automatically. We're going to go into display and active data appearance. Okay, so that was the little pinwheel way over here, which the only value in making an entire new page is this entire toolbar would have been there, but you can just click on these little arrows. What? Whoa, okay. I don't know why that was so small. Data appearance. Show connecting lines. Uncheck. There we have it. And now the only thing that we're seeing, let me get rid of my little highlighter tool, is the line of fit. I got rid of it. There we go. So now there's just one line showing the fit of the data. That's our solution. This tells us, we could add some labels and things to the graph, but ultimately this tells us that the spring constant of the spring we're working with is 16.1 newtons per meter. Okay.